So this is going on page 47 when we are done. Okay, irrational zeros, which I know you've already had to factor and use when you're doing some of your delta math stuff. So I was thinking this morning, I don't know why I don't do this way earlier on, but either way, let's talk about this. So it says to find all the zeros, and we're going to write our answers in simplest form. So we're going to have to factor. So when I multiply 4 times 8, it gives me 32 because a is not 1, so I can't just start with my little parentheses. Since I want to find my zeros, I'm setting this function equal to 0. And then I'm going to split that middle term, so 4x to the 4th. Two numbers that multiply to give me 32, combined to give me a negative 33, will be negative 32 and x squared and negative x squared plus 8. Right? So then I can factor by grouping. This gives me 4x squared times x squared minus 8 minus 1 times x squared minus 8, which then gives me 4x squared minus 1 times x squared minus 8. Okay, so can I factor this part more? This one? You can't? What is this? It's a difference of squares. I can totally factor that more, yes. So this is 2x plus 1 times 2x minus 1. Can I factor this part anymore? No, it is not a difference of squares. 8 is not a perfect square. So I have x squared minus 8. So now that I have it all factored, I'm going to find my zeros. So I know here that what I'm doing, I'm going to write out more on this one than I normally do just so we can think about what we're doing here. We set each little term equal to 0, right? So when I do that, I know that I get x equals negative 1/2. When I put 2x minus 1 equal to 0, that gives me x equals 1/2. And then x squared minus 8 equal to 0. That gives me gives me x squared equals 8. Then I have to take the square root of both sides, so x equals plus or minus the square root of 8. And then what does that simplify to? Because I can't leave it the square root of 8, not 2 square root of 2. If you do not know how to simplify square roots, go back to the summer assignment that you didn't do and do those parts, because if you did it, you would know how to do it. So now I have my zeros, x equals plus or minus 1/2 and plus or minus 2 square roots of 2. So we are talking about irrational zeros because these are zeros. They are intersections on our x-axis, but 2 square roots of 2 is an irrational number. The square root of 2, if I find the decimal, I cannot write that decimal as a fraction. If you can write a number as a ratio of 2 other numbers, that makes it a rational number. That's why 1/2 is a rational number. 0.5 is a rational number. 0.3 repeating is a rational number because I can write it as 1/3. But if I can't, then that's what makes it irrational. Okay? Everybody good with that? Okay. So let's look at number 2. So this is 4 terms. So I'm going to factor by grouping, set that equal to 0. I can factor out a 3x squared. That leaves me with x minus 5. And then I can factor out a negative 4. That leaves me with x minus 5. So I have 0 equals 3x squared minus 4 times x minus 5. Is this a difference of squares? No, it is not. And this is already a linear factor, so I'm good. So then I just solve these. So this would give me that 3x squared equals 4. And skip the first step. That's fine as long as you understand what you're doing. So then x squared equals 4/3. So then I take the square root of both sides. And I'll get x equals plus or minus the square root of 4/3. And when you write something like that, you got to make sure that your square root is tall enough that the whole fraction fits underneath there. I can rewrite that as plus or minus the square root of 4 over the square root of 3. And then that gives me plus or minus 2 over the square root of 3. Am I allowed to leave it like that? No, what's wrong with it? The square root in the denominator. So you got to rationalize the denominator. That would be the square root of 3 over the square root of 3. So that means that gives me that x equals plus or minus 2 square roots of 3 over 3. If you do not know how to rationalize denominators, go back to the summer assignment you didn't do and do it, because then you will know how to do it. All right, so then here, this just means x equals 5. So my zeros then are plus or minus 2 square roots of 3 over 3 and 5. Okay. What questions do you have? Anything? Okie dokie. Then grab your other piece of paper. And let's talk about the fundamental theorem of algebra. All right, and this is going on 48 when we are done. So, just as a polynomial function can have real zeros, like we've seen, they can be rational or irrational, like we just found, it can also have complex zeros. We're going to find all the zeros of the polynomial functions and simplify everything. So, when we start talking about complex numbers, or like the first time you talked about complex numbers, you were introduced to I. What does I equal? Any ideas? It's the square root of -1. Yeah. So if I have the square root of -36, until you get to Algebra 2, you're always told you can't take square roots of negative numbers. That's a lie. You can take the square root of a negative number. It's just not a real number. The square root of -36 is the same as the square root of 36 times the square root of -1. That's why the answer then is going to be 6i. It's an imaginary number. Okay, part of the complex number system. All right, so now let's look at number 1. We're going to factor, and we're going to find all the zeros. So 0 equals, a is 1, that's great, so I can jump to my 2 parentheses here. And I will get x squared and x squared. 12 is negative, so the signs are opposites. What are my 2 numbers going to be? -6 and +2. Okay? And then, is this a difference of squares? No. Is this a difference of squares? No. 6 is not a perfect square. So I can't at this point factor anymore, right? But so from here, I've got to find my zeros. So when I do this, I'm going to get x squared equals -2. So x is equal to plus or minus the square root of -2, which means that x is equal to plus or minus I times the square root of 2. Okay, it's an imaginary number. This one will give me that x squared equals 6. So x equals plus or minus the square root of 6. So what this tells me is I have a 4th degree polynomial. I have a total of 4 zeros, but only 2 of them are real. So even though this is a 4th degree polynomial, it's only going to cross the x-axis twice. Okay, then the other 2 zeros are imaginary. My answer here then for my zeros, because it says to find all of them, is plus or minus I times the square root of 2 and plus or minus the square root of 6. What questions do you have? Anything? Okay, then let's look at number 2. Whew, my board is being slow and weird. All right, So a is not 1, so I'm going to multiply 4 times negative 8, gives me negative 32, which tells me that I can split my middle term, 4x to the 4th. Let's see, this will be a positive 32x squared minus x squared minus 8. So now that I have the middle term split, I can factor, and I will factor out a 4x squared. That leaves me with x squared plus 8. Factor out a negative 1. That leaves me with x squared plus 8. So 0 is equal to 4x squared minus 1 times x squared plus 8. Can I factor that first one more? Okay, thank you. Is the first one a difference of squares? Yes, it is. So 0 is equal to 2x plus 1 times 2x minus 1. And then this is not a difference of squares, so that is x squared plus 8. Okay? Okay. Here you go. You can go ahead and go. You can go ahead and go now. All right. So now I have factored as much as I can right now. So we will go and find our zeros. So I know that this will give me x equals negative 1/2. This gives me x equals 1/2. This gives me x squared equals negative 8. So then x equals plus or minus the square root of negative 8. So x equals plus or minus, how do I simplify the square root of 8? Just the square root of 8. 2 square root of 2. So this will be 2i square root of 2. Because there's a negative in there. So my x's then are plus or minus 1/2 and plus or minus 2i times the square root of 2. Okay. What questions you got? Anything? All right. So let's talk about the fundamental theorem of algebra and our complex zeros. All right, so how we get complex zeros. So I want you to think about, or how we get imaginary zeros. Let's just think about quadratics, because that's what you understand the most. Is that it's possible for it not to cross the x-axis at all, right? It's possible for it to intersect the x-axis once, and it's possible for it to intersect the x-axis twice. Okay? So you have to be careful with wording, because I don't say here that I don't have any zeros. I don't have any real zeros. This would give me 2 imaginary zeros. This would give me 1 imaginary zero and 1 real zero, and this gives me 2 real zeros. Okay? Does that make sense? That's what's happening there. Okay, so the fundamental theorem of algebra says a polynomial function of degree n, where n is greater than or equal to 1, so it could be a linear or more, has at least 1 zero in the complex number system. Okay, so let's think about what that says. We have at least 1 zero in the complex number system. So you most likely never talked about the complex number system until you talked about imaginary numbers. So although imaginary numbers and complex numbers are completely related to each other, they are not exactly the same thing. Being a complex number does not automatically make you imaginary. Because if it did, this wouldn't make any sense. This says, so this is a polynomial function, right? We agree with that. The n is greater than or equal to 1. It says it has to have at least 1 zero in the complex number system. Well, we just said it has 2 real zeros. It doesn't have any imaginary zeros. But it does have 2 zeros that are in the complex number system. Because this says right here, any real number is also a complex number. Let's talk about why that is and how that works. So a complex number looks like this. A plus or minus B times I. Okay? So let's say we have a complex number like 2 plus 3i. That's a complex number. Well, in this complex number, if a were to equal 0, then that would mean I have 0 plus 3i, which is just 3i, which is like the imaginary numbers we got up there. There was no plus or minus anywhere. That's a complex number. If b is equal to 0, then I would have 2 plus 0i, which is just 2. So 2 is a complex number. It just has a 0 with the imaginary part. Okay? So wording here, understanding where which categories the numbers live in is important. So if you were to look at a little number family or like a Venn diagram or something, in with the complex numbers, we have all of our real numbers plus all of our imaginary numbers, because it just depends on which part of this you're using. Okay, so that's why this makes sense. This doesn't necessarily mean imaginary. All right. So let's look at how we're going to use this. Where you're using this for linear factorization. Because I want you to think about right here when we factor these two are linear factors. This is not. This one didn't have any linear factors when we were done. But this says if c is a complex 0, which it's going to be, of a polynomial function, then x minus c, make sure I'm writing what I want to write here, is a linear factor of the polynomial. Okay. Which we've talked about that before, basically. So this means that all polynomial functions can be completely factored. We didn't completely factor those first two on the front, but we're going to. Let's see how that works. So this first example is the exact same as the first one we did on the front. So I'm just going to run through the factoring real quick because we've already done it. So let's find our zeros again. Oops. So 0 equals, this can be x squared and x squared. 12 is negative, so it's plus and minus. Plus 2 minus 6. Right? We couldn't factor. We said we can't factor anymore, so then we found our zeros. We got that x squared equals negative 2. So x equals plus or minus I times the square root of 2. Here, x squared equals 6. So x equals plus or minus the square root of 6. So my zeros are plus or minus I times the square root of 2 and plus or minus the square root of 6. Okay, that's the exact same thing we did on the very first one on the front. Just rewriting it. All right, so it says find all the zeros of the function. We're done. We did that. We did it on the front already. It says then find the complete factorization of the function. All right, so since I'm going to use this to find the complete factorization, I'm going to rewrite these zeros individually instead of with the plus or minus. So I have a negative I times the square root of 2, a positive I times the square root of 2, a negative square root of 6, and a positive square root of 6. Now, you need to pay attention to how we put this into the factorization, because remember, the factor is x minus c, not x plus c, it is x minus c. So when I go to put this in here, I have all my zeros. F of x is equal to, okay, so this will be x minus a negative I times the square root of 2 becomes plus I times the square root of 2 times x minus I times the square root of 2 times x minus a square root of 6, so it's x plus the square root of 6, times x minus the square root of 6. And now this is completely factored. Okay. Now, this doesn't mean that every single time we factor, we're going to have to factor with the imaginaries and the irrationals every time. It's only when you're asked to do it. Okay, what questions do you have? So when I asked you on this one, well, on the front, we stopped here and I said, can we factor anymore? And the answer was no. And for you right then, the answer was no. We can't factor any more easily or with the way we've been factoring, but the truth is we can factor it into linear factors because everything can be factored into linear factors. Okay, what questions you got? All right, let's look at number 3. So we're going to factor 9 times a negative 4, negative 36. So 0 equals 9x to the 4th. And then 2 numbers that multiply to give me 36. I'll have a positive 36x squared minus x squared minus 4. Then I'm going to factor. So 9x squared times x squared plus 4 and minus 1 times x squared plus 4, which gives me 9x squared minus 1 times x squared plus 4. Okay, can I factor this first one anymore right now? Is this a difference of squares? Yes, it is. So this is going to be equal to 3x plus 1 times 3x minus 1. This is not a difference of squares, so I'm going to leave it as x squared plus 4. Okay, so now I'm going to find my zeros. This is going to give me x equals negative 1/3. X equals 1/3. And then x squared equals a negative 4. So x equals plus or minus the square root of negative 4. So x equals plus or minus 2i. Okay, so I'm going to use this for my factorization. So I'm going to write all 4 of them out instead of using my plus or minus. So I will have a negative 1/3, a positive 1/3, a negative 2i, and a positive 2i. When I go to write these, I don't get to just plop them all back in there like I did before, because although up here, I've used whole numbers before, we've used square roots, we've used imaginary numbers, all that's fine. One thing that's not fine to have as your C is a fraction. So I am not going to put, when I have f of x equals, it's not going to be x plus 1/3. Doesn't work that way. We've got to think about where that came from. We know exactly where that came from, right here. So let's think about what's happening. If x is equal to negative 1/3, I'm not going to say x equals, I'm not going to say x plus 1/3 equals 0. That's not what's happening. We can't have a fraction. So we start up here. So if we didn't have this, if you were just given the zeros, which is a possibility, then we'd have to multiply through by 3. So I'd get 3x equals negative 1. So 3x plus 1 equals 0. That's your actual factor. Okay? And that's how you get it back out of a fraction, if it wasn't like right in front of your face like it is right here. So that means this negative 1/3 gives me 3x plus 1. This positive 1/3 gives me 3x minus 1. Then x minus a negative 2i is x plus 2i. And then x minus 2i. And that is your complete factorization. If it's a 4th degree, you should have 4 factors, 4 linear factors. What questions you got? Good? All right, then you do number 4 on your own. I will work number 4 in just a minute, but I don't want you looking up here and just copying mine down. Don't look up and check it until you're done. you're done, you can check yourself with me. If we agree and you don't have any questions, go ahead and tape into your ISN and get started on your Delta Math. Pay close attention to that last factor that I have. If that is not what you have, then you do not understand the concept overall, and we need to have a little talk. Okay? If you're still working, that's fine. I just know some people finish quicker than others, so. Doesn't mean you're slow, it just means they're really fast.